practice now 1. A particle, so it's just something, okay? You don't have to, when we say particle, we are telling you, you don't have to concern yourself with the mass, the size, or anything like that. Just treat it as a point that is moving. It is moving in a straight line. It is very important they tell you it's a straight line. Otherwise, things get really complicated if it is moving in a circle or moving in a curve. So it is moving in a straight line. Straight line means only left or right. T seconds after passing a fixed point O. O for origin. So we're going to use O as a reference. And all of its position will be with reference to O. Okay? And the displacement is given by S equals to 4t cubed minus 15t squared plus 18t. Okay, now looking at this equation, tell me immediately, what is its displacement when time equals to 0? You can tell very easily, right? Start 0, you get 0. Okay, it is at the origin when time equals to 0. Now, find the velocity when time is equal to 3. Velocity is given by ds over dt. Good. So differentiate it really quickly. 12t squared minus 30t plus 18. Now this is the expression for our velocity. Meaning, for any time that I require, time equals to half, time equals to 0, time equals to 1, so on and so forth, I can find its corresponding velocity. I'm going to ask you the same type of question again. What is its velocity when time equals to 0? Tell me the answer immediately. Alright, what is the velocity when time equals to 0? 18, right? What does this tell you about its motion when time equals to 0? Is it moving or is it stationary? When time equals 0, what is the velocity? Time equals 0, velocity 18, right? So it is moving when time equals to 0. Is this possible? That it is moving when time equals to 0? Why not possible? You need acceleration, but read the question carefully. They say that it is moving in a straight line such that t seconds after passing a point O. So it was originally moving. It's just like myself walking. Right now I'm stationary, right? I start moving, but I haven't started counting yet. I haven't started timing yet. When I reach a certain point over here, O, I start timing. At point O, when time equals 0, I already have motion. And there is a velocity of 18. You understand? So that is the situation. Now they want the velocity when t equals to 3. When t equals to 3, v is 12, 3 squared minus 30 times 3 plus 18. How much is this? How much? 36. Units are important. What are units? Meters per second. These are obtained from the question. They tell you that S is in terms of meters. In meters. And they tell you this is in seconds. So your velocity will be meters per second. Part 2. Find the acceleration when t equals to 3. So now, acceleration is dv over dt. 24t minus 30. Same type of question again. What is the acceleration when time equals to 0? What is the acceleration when time equals to 0? What does this tell you about the motion when time equals to 0? Just now I was moving, right? So I start counting down, I start timing over here when origin, when I'm at the origin. What does this tell me about my state of motion at this point? It's decelerating. What is another word for decelerating? Negative acceleration. Deceleration is negative acceleration. There's another name for it, isn't it? That starts with R. Retardation. Yes, retardation. Our favorite word. Okay, retardation. In this case, am I slowing down or am I speeding up when time goes to 0? I am slowing down. I am slowing down with an acceleration of 30 meters per square second at time equals to 0. Okay, so this is what is happening. Now when t equals to 3, our acceleration is 24 times 3 minus 30. How much is this? 42, is it? Okay, 42 meters per square second. Now what does this imply at time equals to 3? Am I speeding up or am I slowing down at time equals to 3? I'm speeding up at time equals to 3. And what is my velocity at time equals to 3? 36 meters per second. Do you have an idea of what's happening right now? Okay. Find the values of t when it is instantaneously at rest. What does that mean? Instantaneously at rest means it is not moving for that moment, that particular instance in time. Okay, so when it is not moving, it means that v is equal to 0. So we have to go back to our expression for velocity. We set it to become 0. Okay, so for part 3, when v equals to 0, we divide all this by 6 straight away. We get 2t squared minus 5t plus 3 equals to 0. Is this, are we able to factorize this or must we use the formula? 2t minus 3. Is it? My stylus. 2t minus 3 times t minus 1. Yeah, sounds correct. 2t minus 3, t minus 1 equals to 0. So t, equals to 3 over 2 or 1. What does this tell us? When time equals to? It is at rest. Okay, at these two timing, right? So for convenience, let me just put a smaller time in front, okay? When time equals to 1 or time equals to 3 over 2. So it is moving, okay? We know that when time equals to 0, it was already moving with a velocity of 18, but it was slowing down. So slowing down, until time equals to 1. When time equals to 1, it stopped moving. Velocity was 0. What does that imply about this object? Turning point? It is turning. So it is rewinding to go to the other side. Okay? Now it is going to continue traveling like this for how long more? 0.5 seconds. Then what happens again? It turns around again. And then it goes back in this direction. Okay? And when the next significant time of day is when time equals to 3. That is what we found earlier on in the part 2 and part 1. Wait, one by one question by one question. Yes, who wants to ask? Yes? How do I know if it is turning instead of just stopping? Well, after time equals to 1, if it is stationary already, what will the velocity be after time equals to 1? It should be 0, right? If it is stopping forever already. Just substitute in another value of 1.1. What happens to the velocity when time goes to 1.1? It is not 0. So there is a velocity. It is just instantaneously at rest over here. Okay? Yes, so do you have a question? Huh? Why would it want to turn and turn? You're asking why it wants to turn and turn? I don't know. They designed the question this way. Okay, so these are the two times when it is instantaneously at rest. Okay, now part 4. Find the total distance traveled in the first 2 seconds. Now, I don't want to do part 4 first. Let's do part 5. It is a little easier. Let's do part 5. Find the distance of the particle from O when time equals to 2. The distance from O when time equals to 2. How should we do this? Distance from O when time equals to 2. What formula do we have? What equations do we have? What did they give us? Displacement, right? They gave us displacement. Originally, they said that S equals to 4t cubed minus 15t squared plus 18t. This is the displacement. Now they're asking for distance from O when time equals to 2. So what should I do? Integrate this for what? This is displacement. You integrate displacement, what are you going to get? Alright? what should I do? Sub t equals to 2 inside. I sub t equals to 2 inside, what will I obtain? Displacement or distance? Displacement. If the displacement is positive, is that the answer already? Listen again, Listen. If I sub t equals to 2 inside here and the answer is positive, is that my answer already? Why not?
Yes, because of the wording of the question. Because of the wording of the question.
Hey, the question says, the distance from O when time goes to 2. If I sub inside and then the displacement is positive, wouldn't that be the distance? Yes, right? But if I sub t equals to 2 inside and my displacement is negative, is that my answer? Just change to positive. You modulus it, then you get an answer. Can? That is to get distance. Okay, let's do this now. Part 5. When t equals to 2, s equals to 4, 8, 15, 4, 18, 2. How much is this? 8. This means that it is in a positive direction, 8 meters. Okay, when t equals to 2. This is also the displacement. Now what about part 4? Do you expect the answer to be the same in part 4? Why not? Huh? Total distance? Why can't the total distance be 2? They change direction. When did they change direction? At t equals to 1 and 1.5. So let me illustrate to you. This is the origin, this point over here. Okay, I'm going to pass this region, I'm going to pass this stage with an initial velocity. Okay, and I'm slowing down. When time equals to 1, my velocity slowed down to 0. So I headed the other direction. Right now we are interested in part 4, the distance traveled when time equals to 2 seconds. Right now, time equals to 1 second. I have to consider this distance so far, right? Then I U-turn. This distance, do I also want it? Yes, I want it. And I reach time equals to 1.5. Then I change direction again, isn't it? Is it really times 2? No. We have to figure it out. Then after that, I continue moving in this direction. And when time equals to 2 finally, I have to add back this stage of the distance. So can you visualize how many portions there are? 3. Then there is 1 over here, right? From here to the first starting point, that's 1 stage. Then another stage over here, 2. Then another stage all the way here, right? Until time goes to 2. So we need to find out all these distances. And we are going to do that by drawing, by sketching out the path traveled. Okay, so this is simple. We got it out of the way already. Part 4. For this type of question, this is what you are encouraged to do. You draw a horizontal axis. We will call this displacement. Okay? Instead of visualizing it by time, we visualize by displacement. Okay? So this is in meters. At time equals to 0, what was its displacement? 0. Okay? So over here, this is the displacement 0. So let us draw our particle over here. We label it as time equals to 0. Okay? So there are a few aspects to this diagram. The horizontal axis is the displacement. Helps us visualize where it is at whichever time that we are interested in. Time equals to 0, it is at displacement equals 0. We're going to assume that right hand side is positive. Up to you. You want to choose the left hand side as positive, it's fine, as long as you're consistent. Okay? But by convention, we choose right side as positive. So now, it is going to travel to the right. What is the next significant time?
Turning point 1.
At time equals to 1. At time equals to 1, it is going to U-turn, isn't it? Okay, so let us do a U-turn over here. And at this point, we will call it time equals to 1. Okay, so my timing is written above here. On my horizontal axis, it is my displacement. What is the distance when time equals to 1? Did we know? Do we know? Not yet. Can we find out? Very simple, right? Substitute time equals to 1. When time equals to 1, our displacement is 4 minus 15 plus 18. How much is that? 1. Not really 1. No lah. 37. Okay? So this displacement over here is 7. Okay, now I know already. I was moving for 7 meters, then I U-turn. Okay? Now, I'm going to U-turn for a duration of how long? For another how long? Another 0.5 seconds. Then I'm going to U-turn again. This is at time equals to 1.5. Okay so far? Okay, the diagram so far? Right, what is the... Now we are interested in this distance, isn't it? I want to know this value. What should I do to find out? Sub t equals to 1.5. Do you all agree? Because when I sub t equals to 1.5, I get the displacement. Okay, I don't have to be bothered that, oh, actually when t equals to 1.5, it is already beyond here, make a turn here. That doesn't matter. That's the beauty of displacement. Displacement tells us where it is relative to the origin. Okay? So at time equals to 1.5, I substitute straight away. I will get its displacement from O. And this point is what I require. Okay, so when t equals to 1.5, displacement is 4, 1.5 power 3 minus 15, 1.5 square plus 18, 1.5. How much is this? 6.75. I will assume that you are correct. Huh? So this is 6.75. Does the value make sense to you? That 6.75 is on the left hand side of 7 and yet it is on the right hand side. Makes sense, right? Because that's how U-turns work. Of course, this value must be smaller. Any questions so far? Yes, Tracy? Correct. From shortest distance from O to time equals to 1.5, this is 6.75 meters. Yes? Okay, when I draw this diagram, so the U-turn doesn't happen this way. No, the U-turn happens this way. Okay, you all come. Yes? 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 Okay, now, this is time 1.5 so far. Are they interested in 1.5 only? No, they still need time equals to 2, right? Do you remember where it was at time equals to 2? Just what we did for part 5, right? When time equals to 2, s equals to 8. We did part 5 earlier on already. So time equals to 8 must lie somewhere here. So when distance is 8, it must be over here. So let us extend this. This is time equals to 2. Now based on this, can you now find the total distance? This is 7 plus, how much is this? 0.25 plus, how much is this? 1.25. So total distance is 7 plus, this is 0.25 plus 1.25, and we get 8.5 meters. Are the answers the steps for part 1 and part 2? Generally, I don't think you guys have problem. Just that you all seem to have some inertia about differentiating your trigo again. Okay, so moving on to part 3. The acceleration when it first comes to rest. Okay, let's break this down. Acceleration, you know that it is dv over dt. So differentiate your velocity, we get differentiate of velocity, we get negative 16 sine of 2t. But this is not the acceleration when it is at rest. This acceleration is a function of time. In other words, I need to supply the time value in order to get the corresponding acceleration. I want the acceleration when it is not moving, meaning I need to substitute in a certain value of time when it is not moving. And what does it mean by it is at rest? Velocity equals 0. So we are supposed to find out what happens when v equals to 0. Then we get cosine 2t is negative 3 over 8. Okay? Cosine 2t is negative 3 over 8. What's the next step? Huh? All the alpha, everything, right? First, tell me which quadrant is this in? Second or third? So in the second quadrant, we have 2t equals to pi minus cosine inverse 3 over 8. Or in the third quadrant, it will be pi plus cosine inverse 3 over 8. You go and revise. Okay, so these are the two values, and they tell us they want the acceleration when it first comes to rest. Here I have two values which will show me when it is at rest. Which one should I choose? The left side or the right side? Left side or right side? Left side lah, the one that is smaller. This is pi minus something, the other is pi plus something. I must choose the left hand side. So this is rejected. We don't have to go and solve for t. All I require is 2t, because now I'm going to substitute this inside here.
So what topic is that?
Trigo. Okay, substitute inside and get the answer. Round it off if required. Can? You ready for practice now 3? Yes. Okay, let's go. Yes. Let's do it. Practice now 3. You have 15 minutes. Let's get part 1 and part 2 out of the way first. S 40 plus 30t minus 5t squared. Height of building. Height is when t equals to 0. Okay? Because it starts from the top of the building. So height equals to S equals to 40. Done. 40 meters. Okay? Don't overthink things. Part 2, velocity. V ds over dt. 30 minus 10t. When time equals to 2, v is 30 minus 20, which is 10 meters per second. T equals to 4. Velocity 30 minus 10 times 4. Negative 10 meters per second. So in these two cases, when time equals to 2 and when time equals to 4, they have the same speed. Am I right? They have the same speed, but velocity is different. Look, magnitudes are both 10 meters per second, but the direction is different. So the significance of the values over here, when time equals to 2, speed equals to 10 meters per second, and it is traveling upwards. Okay, we see that from the question. S equals to 40 plus 30t minus 5t squared. And we say that when time equals to 0, we get the height of the building. When time equals to 0, the height of the building is positive 40. Now, the building must be above ground, right? That's why we call it height of building. So, in this way, we are already taking upwards as positive. Okay, the direction up is positive. Now, when we have the velocity as positive, it means that it is traveling upwards. Next, when t equals to 4, the speed also equals to 10 meters per second. Speed is a scalar, no direction. But because here we are talking about velocity, we will say, and it is traveling downwards. Okay? This is part 1 and part 2. Next, part 3. Find the values of t when it's a height 60 meters above. So S, 40 plus 30 t minus 5 t squared. Apparently this is equal to 60. You go and solve, you will get, what is the smaller value of t? 0.764. Or t equals to 5.224. Okay. So these are the two timings that we have. So the situation is this. This is ground. Okay, the height of the building is 40 meters. We are going to throw the ball upwards. When time equals to 0, it already has a velocity. When time equals to 0, it has a velocity. Does that surprise you? Is it strange that when time equals to 0, there is a velocity? Shouldn't be. I demonstrated earlier on, right? I demonstrated it earlier on. I was already walking with a certain velocity. Then I start the timer. So that is an example when time goes 0, velocity is already something. Another example that we have is when I throw a pen, or when I throw a marker, whatever it is. When I throw something and I start timing when it leaves my hand. Okay? Listen again. The situation is I'm going to throw this marker and I'm going to start timing when it leaves my hand. So when it leaves my hand, did it have a velocity? Yes. Yes, it must have a velocity. Otherwise, it would have been still in my hand. And that is actually supplying it with kinetic energy, right? So it is going to move up. When time goes 0, there it has a velocity. Therefore, it has kinetic energy. Then it can go up. So over here, when time equals to 0.764 seconds, it has a displacement of 60 meters. So this is the point when time equals to 0.764 seconds. Beyond that, did it continue to travel up? Beyond time 0.764 seconds, did it continue to travel up? Did it go down from here already?
Yes. No.
Use your logic.
No.
If it goes down from here, then how can you get t equals to this one at time at displacement equals 60? It has to go up further. Yes, it is a parabola opening downwards. Okay, so it is going up. At this point, time goes to 0.764. It has a displacement of 60. It reaches the maximum point. Nobody asks you to find out what the maximum point is. Doesn't matter. But we do know that when it comes back to this point, same displacement, it will now have a time of 5.245 seconds. Okay? So explain the significance. Well, at time equals to 0.764 seconds, it is traveling upwards. And displacement equals to 60 meters. Whereas for this case, it is traveling downwards, and displacement equals to 60 meters. Okay, same displacement, but its direction of travel was different.